Hello, my name is Idan Kantor from Dell EMC. In this demo, we'll see how easy it is to protect vVols residing on PowerStore to cover for virtual machines. We'll cover a few use cases, but first of all, let's start with a quick intro to the environment. This is my vCenter, the New York side, where I have my vVol data store for PowerStore. Let's quickly navigate to the New York PowerStore and its PowerStore manager. Over there under the storage container, we can see the VMs using vVols on that container. Now let's switch to the vCenter of the second side, Barcelona, where I have a vVol data store provision from another PowerStore array. Cool. Let's head back to the New York vCenter and protect the VM. As you can see, this VM is leveraging vVols. We'll navigate to the RecoverPoint for VMs tab under Configure for the VM we wish to protect. The Protect VM wizard appears. It's a really simple wizard which comes to provide a true next sort of experience. We'll create a new consistory group and call a prod app. As you can see, at production journal will be using vVol. We'll configure remote replication to Barcelona. The replica journal also uses vVol. We'll go with the default RPO of 25 seconds, and the RPVM will always strive to get the lowest RPO possible. The replica VM itself will also leverage vVols. Failover networks can be configured here during initial protection or post-protection. Finally, we'll click Protect, which would start the protection process and would also by default start transfer. Replication has started, as you can see. Let's fast forward a bit. And transfer is active, meaning the VM is protected. And to our advanced VM protection demonstration, we would protect two additional VMs which are part of the same application, the same consistory group. Here's the glorious Protect VM wizard again. This time we will add this VM to an existing CG and protect additional VMs using the same consistory group. Let's select the additional VM, Linux DB01. Now per VM we can configure advanced options. In this case, we'll include the VMDK for replication. We'll let the RPVM create the replica VMs and place them on the auto-populated compute resources on the replica side, Barcelona. Replica also uses vVols. Finally, click Protect. The added VMs and their VMDKs are now being replicated. This has no impact on journal history, and we're good to go. The added VMs are now protected. Now the final part of the demo would include a demo of our main orchestration capability, startup priority, as well as the R test. For that, let's navigate to the RP for VMs vCenter plugin. Under the CG we just created, we'll click on Edit Startup Sequence. Most of the orchestration capabilities can be configured here, like startup priority, user scripts, prompts, and criticality. In this case, we want our database server to start up first, followed by the app and web servers, so we'll edit the priority accordingly. Now let's create a bookmark which is being created just before our application was upgraded. We'll then perform a DR test by launching the test copy wizard. We'll select the bookmark we just created as the image to access. We'll test in an isolated network which RPVM creates. RPVM will associate the VNX of the replica VMs with that network. And image access is enabled. We'll hide the wizard and head over to the vCenter on our replica side, Barcelona. As you can see, our database server Linux DB01, which was configured with the highest priority, had been started first. The VMs of the next priority group would start only after the guest app is up and running on the replica VM, meaning when we get heartbeat from the VMware tools. As our database VM is up, our application VM had begun the startup process. Let's make sure the guest OS is up and running. And finally, the web server VM is now also powered on and its guest OS is up and running. Cool, all replica VMs are up and running now. The last thing we need to do is to tidy things up and finish our DR test. There you have it. Thanks for watching and see you in the next demos.